24-hour endurance race is one of the most brutal tests in all of engineering. It relentlessly tests how a vehicle manages mass and mechanical stability when subjected to extreme sustained racing velocities. In 1991, Mazda became the first Japanese manufacturer to survive this test and win the 24 Hours of Le Mans. They achieved this against a grid dominated by traditional engine architectures. The heavily favored legacy teams relied on large V8 and V12 piston configurations. Manufacturers like Porsche, Mercedes, and Jaguar trusted these proven reciprocating mass engines to endure the immense physical toll of the race. Mazda chose a highly unconventional alternative. They powered their 787B with the R26B Wankel rotary engine. This diagram shows the packaging discrepancy. On the left is the massive profile of a standard V8, and on the right is the compact R26B rotary. The 787B abandoned reciprocating mechanics entirely, opting for a topology based on continuous rotation. Rethinking the engine's foundational topology gave this underdog the means to compete outside the mechanical constraints that governed the rest of the grid. This kinematic comparison shows a standard piston engine on the left. It relies on reciprocating mass, constantly halting and reversing direction, which causes severe energy waste. On the right, the rotary engine's triangular rotor spins continuously, converting combustion directly into unbroken, fluid angular momentum. With no reciprocating mass dragging the system down, the rotary engine operates with significantly lower internal friction, allowing it to spin at drastically higher RPMs. Eliminating that start and stop stress provided the specific physical mechanism that enabled the 787B to maintain its structural integrity for the full duration of the race. Mazda amplified this continuous rotation by configuring the R26B as an inline quadrotor. They stacked 4 independent rotors together to act as a single unified power block. The immediate engineering challenge is air volume. A quadrotor at maximum velocity requires a massive oxygen supply. Mazda solved this with continuously variable intake runners. Telescopic tubes physically adjust their length in real time, optimizing airflow dynamics across the entire RPM band. The exhaust phase is similarly streamlined, operating completely without a traditional valve train of cams, springs, or poppet valves. Eliminating these mechanical valves removes primary restrictions. Spent gases evacuate the chamber rapidly through large open ports, without any mechanical gates impeding their path. This precise, unrestricted breathing allowed the R26B to rev freely all the way up to a staggering 9,000 RPM. That precise combination of high-velocity exhaust flow and continuous rotation generated the 787B's famous high-pitched screaming acoustic signature. Pairing continuously variable intake airflow with a valveless exhaust allowed continuous rotation to operate at peak efficiency, yielding a perfect endurance racing power plant. This table maps the engine's volumetric density. The R26B produced roughly 700 horsepower from just a 2.6-liter equivalent displacement. Because it produced so much power for its size, engineers shrank the vehicle footprint, resulting in a total chassis weight of just 830 kilograms. Over 24 hours, an ultra-lightweight chassis translates directly into a massive agility advantage, heavily reducing wear on consumable components like tires and brakes. The 787B ran flawlessly during the 1991 race. Reduced mechanical stress and low mass kept it on the track while heavier, traditional competitors broke down. Maximizing this weight advantage, the high RPM vehicle reached top speeds of roughly 215 miles per hour on the infamous Mulsanne Straight. Pure volumetric density and reduced stress created the lightweight agility required to outlast heavier, complex machines. In its final, race-winning form, the 787B demonstrated rotational combustion could survive and outperform traditional engines on the world's most demanding circuit. The architectural efficiency of the rotary was so radically distinct that standard V8 and V12 manufacturers could not counter it using existing methods. The governing body of motorsport reacted immediately following the 1991 race. The FIA introduced new regulations in 1992 that explicitly shifted the rule parameters, effectively banning rotary engines from competing in the top tier of sports car racing. This rapid regulatory ban inadvertently cemented the Mazda 787B as a permanent, unbeatable historical anomaly. It remains the first, the last, and the only rotary-powered car to ever win the 24 Hours of Le Mans. By perfecting rotational physics, the 787B broke the established parameters of motorsport forever.